folks, in this video we're going to take a quick look at how we can use global variables and reference those across multiple processes. Now, this is an important technique to learn because it can really affect how you write your processes. And you can create very discrete, focused processes that perhaps perform a single function and then reference that from other processes when you need it. It's going to save you some maintenance time because you're writing the code in one place. Now, the example that I'm going to use today is a little bit based on probability math, so we're going to create some functions that don't exist natively in TM1, and we're going to reference those. So we're going to create a factorial function, a combinatorial function, and also a permutation function. They're all closely related, and they all use the factorial function significantly. So you're going to see how we can create that one factorial function and then reference that from the other two very easily. So not necessarily something you'll be doing a lot of in TM1, but it does make a quick and simple example for us to use. So let's try that.
So for this little exercise, I've created a folder for my combinatorial functions, and we're going to start with a new process. This process is going to have a single parameter, which is going to be, of course, factorial. No surprise, that will be a numeric parameter, and I'll specify a default value here to make it easy to test. And of course, I always enter a prompt question as a means of documenting the parameter that we expect. Now, for anyone who doesn't remember the factorial function from math class or hasn't used it since, it's essentially the product of all positive integers less than or equal to the number. So in this example, 5 factorial is the product of 5 times 4 times 3 times 2 times 1. So as I'll often do, I've created a region at the top for my variables. Want to see my variables, what I'm setting and expecting as the contents of those variables. Also want them in a region so I can collapse it and avoid cluttering my screen. I have a variable to store my result, which I'm initially setting to 1, and another that I'm going to use to iterate through a loop. The last thing that I want to do in my variable section is force the parameter that's being passed to the function to make sure that it is an absolute number, so a positive integer, and that it's rounded. We don't have any decimals. We do again want an integer. Anything else will fail in this function. That's not a weakness of my function, it's a weakness of math. You can try that on your calculator. So I'll just close my variables region here and start another region where I'm going to loop through the integers that are less than or equal to my factorial. In each step of that loop, of course, making my factorial result the product of it times the integer. Now our function would work just fine like this, but because we're not doing anything with the result, we won't actually know what it is. So let's just add an ASCII output to dump the result of that out to a text file, and we'll be able to review our result. All we have to do is save and execute our process. My default parameter value there. With no location specified, that's of course going to my data directory. I look at my result file and I see the answer 24. So now let's move on to our combinatorial function. So I'll say OK, restore my window here and create a new process to combine. This function, of course, is going to actually have two parameters because we want a number that we're going to take values from, and then the number of values we're taking. So if this were a deck of cards, of course, we'd be picking perhaps a hand of 5 from a deck of 52. And I'll actually use that in my prompt question so I know which parameter is which. So I'll give that a default value of 52. And then my number chosen will be 5, and we'll create our function. We'll do another quick math refresher here, remembering that if you were to choose 5 cards from a deck of 52, the odds after you've chosen the first card are reduced because there are no longer 52 cards in the deck, there's 51, you've already got one. So the odds of a particular hand are the number available, factorial, divided by the product of the number chosen factorial and the number minus the number chosen factorial. So getting a royal flush of hearts, 1 in 2,598,960. Not great odds. So as you can see with a formula like this, we're using that factorial function a number of times. We have two choices. We could write that over and over again in our script, or we can just reference that factorial function we created as we step through the various parts of this formula. There are two keys to being able to create your processes such that you reference one from another. The first key is the one you'll see here, which is defining a global variable. By default, all variables are local to the process they're created in. The values stored in them live and die with the process. If you're going to be referencing other processes and returning values from them, then you need to do that as a global variable, like I'm doing here for my v factorial result. The other thing you want to consider, because these are available to other processes and they actually live outside of the life of the process, is how you name them. You want a name that's unique to the process result so that you're not confusing things if you've got a lot of processes using this technique. Don't use a name that's ambiguous like result or X or Y or something like that. The next set of variables I'm going to create here are going to be local variables that are going to store the result of my factorial function for the necessary constituents of this formula. I'll add another variable to store the result of my combinatorial function, so my final result, close my variables region and open a new region where I'm going to call my factorial function. And this is the second key to building reusable, discrete processes that do a particular thing and then reusing that, which is of course calling out to the necessary function. We do that in TM1 with the execute process function, which I'm using here. The thing to understand about the execute process function is that it has a variable number of parameters. So it will always have the first parameter as the name of the process you want to call, obviously, but the following parameters are pairs of parameters that you want to send to the process you're calling. First, it'll be the name of the parameter in the function you're calling. The next will be the value for that parameter. The rest of the code in this region is essentially just setting those variable values I defined above by calling out to my function and capturing the result. Again, sending those parameter name, parameter value pairs with the execute process function call. The last region I've created here is the actual calculation, which puts all of this together with the three results we've just requested, and then as we've done previously, dumping the net result of that out to a text file. So now I'm going to save that function, but I'm going to do one other thing before we try it out. And this is really important as you start building these connected processes. When you define a global variable, you need to define that in both the master process, so the one that's calling out to other functions, as well as in the sub-processes themselves. So I'm calling my process here. I need to make sure that I define the global variable there exactly the same with the same name. So now, let's try it out. You may recall from the math that we had done off to the side that we were expecting a result of 2,598,960 for those parameters. So now you know how you can join multiple functions together, call out to one, return a result using a global variable. Let's just repeat this one more time to create a permutation function. I'll say OK, restore our window, create a new process. We'll call our process permutation. We'll add a couple of parameters. We need two parameters for this, just like we needed for our combine function. Like our combine function, we're going to have a number and then a number chosen. Both of those numeric, of course. I'm going to use 10 and 3 as my default values because our example here is going to be like a combination lock, because permutations are really like an ordered combination, where what matters is not only the likelihood of a value, but the likelihood that the values are going to come in a specific order. And now we'll step quickly through our script. So This script will be very similar to the last. We're going to start by setting a numeric global variable for a factorial result. This will be a little easier. We actually only have two constituents that we need to go retrieve a factorial value for. We're going to call that execute process, create the pair of the name of the parameter and the parameter we're passing, retrieve those results for both constituents that we want, and then all we have to do is put that together with our permutation expression. And of course, as we've done previously, dump the results out to a text file so that we can see them. So we'll save and execute our process. Our default values, you'll recall, we were expecting a number of 720. And if we take a look, that's exactly what we get. So the point of this exercise, as I might have mentioned previously, was not so much to show you how you can build a number of combinatorial functions that you're probably never really going to use with TM1, but rather to show you how you can build your processes in a way that's tight and focused and more maintainable. If you find yourself writing processes where you're copying and pasting blocks of code over and over, and you wonder in your head, is there a better way? This is usually the better way, creating separate processes that you call and building a foundation of reusable logic. So I hope you found this useful and use these techniques in your own processes. Thanks very much for your time and happy modeling.